to eventually talk about trigonometric functions, we first need to talk about trigonometric ratios. That is where we define trig values based on the ratios of the sides of a right triangle. We've got a sheet of those here, but let's add our own figure in order to remind ourselves what trig values are. We're going to draw ourselves a triangle. And we'll call this angle A. Now, relative to angle A, we say that this triangle, this right triangle, has one side that is opposite A, another side that is adjacent to A, and a hypotenuse. All trigonometric values are defined using ratios of these three sides relative to A. We say that the sine of A is equal to the opposite side over the hypotenuse. And when we say opposite over hypotenuse, we mean the length of the opposite side over the length of the hypotenuse. The cosine of A is defined as the length of the adjacent side over the length of the hypotenuse. Finally, the tangent of A is defined as the ratio of the opposite side length to the adjacent side length. Let's put that into practice. This sheet is asking us to find the value of each trigonometric ratios. For our first example, we are given a tangent. So remember, tangent of Z. Let's highlight the angle that we're looking at. The tangent of Z. So tangent, remind ourselves, tangent of Z is the opposite side length over the adjacent side length. So in this case, the opposite side is 21, the adjacent side is 28. So what we can say is that the tangent of Z is 21 over 28, and of course, we simplify that. 21 is 3 times 7, 28 is 4 times 7, so this is 3/4. Now that was tangent. Let's take a look at cosine. We'll use space up here. So the cosine of C, again, let's highlight the angle we're talking about. Okay, the cosine of C would be the adjacent side, the 16, over the hypotenuse. Again, we can simplify. This one, they're both divisible by 2. That's going to give us 8 over 17. We'll call it good. Let's move on. This asks us to find the sine of C. Very convenient that they're using the exact same angle position for all of these. Now, remember, the sine is equal to the opposite side length over the hypotenuse. Again, these are both divisible by 7, so we'll simplify, and we will get 4/5. That is the value of the sine of c. You should go on and complete the rest of these on your own. These next problems are calculator problems. We're first going to have to identify the angle. 11 is asking us to find the cosine of z. So remember, cosine deals with the adjacent side over the hypotenuse. Now, the adjacent side here, they've flipped this triangle around, but the adjacent side is still the side that is lying right next to feeding into z. So it's going to be 12. And that's over the hypotenuse. So we got 12 over 15. Once more, we simplify. The cosine of c in the next problem. Oh, this asked for the nearest 10,000th. Okay, well, 4/5. Let's get that as a decimal. 0.8. Great. For this one, for number 12, we're looking at the cosine of c. There's c. Cosine again uses the adjacent side, so the cosine of c will be 27 over 45. And on this one, I'm not actually going to simplify. I'm just going to cut to the chase and get a decimal value. We'll do 27 divided by 45 gets us to 0.6. Some of these are not going to be as pretty of numbers, but you get the idea. Let's move down to number 19. This is asking us for the sine of 48 degrees. Now, this is the situation where we don't have the triangle, and that's okay. We don't need to. This is going to be purely a calculator problem. So for my purposes of using a calculator, I'm going to pull up Desmos. You can use whatever you like. And let's go to functions, put in sine of 48. Now, it's at 48 degrees, and Desmos doesn't automatically enter things in degrees. So we need to check. Let's see, aha, it says it's in radians. So let's change that over. There we go, now we're in degrees. And voila, we get that the sine of 48 degrees is 0.7431. We'll add that back in. 0.7431. Good to go. Problems 23 and 24 are good questions to mull upon, and I'm not going to give you examples for those. I think these are good questions to spend some time with, try some examples, think about whether they make sense, and then bring them to the discussion board or bring them to our video session. Even better if you can poke around online and find some more information that could answer those questions for you.